little bit. What we're talking about the next few days are oblique triangles. We have done a lot of trigonometry, but our trig functions, the definitions of those trig functions, they only apply in what kind of triangle? A right triangle. So everything we've done has required a right triangle. But we know that not every triangle in the world is a right triangle. So if you have what is called an oblique triangle is just not a right triangle. Anything except. It could be acute, it could be obtuse. It's just not a right triangle. Then we can use what's called the law of sines. So if you're taking notes, if you want, you could write down probably just all you would need. Oblique triangle, you just need to know it's not a right triangle. And then the next slide, I'm going to give you a formula, which you will want to write down. So this is the law of sines. This works in any triangle. It does not have to be a right triangle. It applies to any triangle. On test quiz, I would give you this. You would not have to memorize it. You just have to be able to use it. The lowercase a, b, and c represent the sides of the triangle. Uppercase a, b, and c represent the angles of the triangle.
They're all equal to each other?
The ratios are equal. So you could take any two of them. So side a divided by sine of a would equal side b over the sine of b. Just as a note, the reciprocal is also true. Sine a over a equals sine b over b equals sine of c over c. So we can set it up either way.
I feel like I saw a lot of these on
The ACT usually has a question about it, usually not more than one, but they like to also give you formulas when you're not using them sometimes too. So, okay, so really all we're going to be doing is plugging into our formula to solve for things. So here's our triangle. We have triangle ABC. So unlike every other day of trig, this is not a right triangle. In this triangle, I have given you some of the information. I know angles A and C and side A. When I say solve the triangle, that means find everything else. Probably easiest to start by finding our missing angle. Oh, I wrote my picture in my, let's say angle B is 81.8 degrees. Sorry. I said C, but then I labeled it as B in my picture, so let's just fix that. So I'll give you angles A and B. How would I find angle C? So you could do, we know that 32 degrees plus 81.8 degrees plus C has to equal 180. So if you just subtract from the 180, angle C is 66.2 degrees. Now I have to find the missing sides. So we have to start with the only side I gave you was A. So I'm going to use that and my law of sines. So we know that A over sine of A would be equal to B over sine of B. So if I plug that in, my side A was 42.9 over the sine of 32.0 degrees equals B, which we do not know, divided by the sine of 81.8 degrees. How would I solve for B? Yeah. Cross multiply, or you could even just multiply over your sine of 81.8, however you want to do it. And we are going to use our calculators. Make sure you are in degree mode. So I have 42.9 divided by the sine of 32 times the sine of 81.8. Let's do significant digits. Everything here has 3 significant digits, so if I round this to 3 significant digits, I get 80.1, and my sides were measured in centimeters. Are you alright with that? Can I do Pythagorean theorem to find my third side? No, Pythagorean theorem only works if you have a right triangle, so I have to do the law of sines again. I tend to prefer, I'd rather not use this number unless I have to, just because of rounding error. So I am just going to use A over sine A again. And we need to find C, so that would be equal to C over sine of C. So you can set any 2 of those fractions equal to each other. So that's 42.9 divided by the sine of 32 equals C over the sine of 66.2. So if we plug that in, multiply over our sine of 66.2, round to 3 significant digits, and we get 74.1 centimeters.
When you multiply over the sine of the c over here, are you multiplying it by the top and the bottom?
No, it would just go on the top.
I confused myself. So I'm just typing in 42.4 divided by the sine of 32. Make sure you close that parenthesis. So we have that fraction times the sine of 66.2. Oops. Thank you. Did I type in something wrong? Oh, I put 42.4 instead of 42.9. That's why your answers are skewed.
Just as a quick check, in your triangle, your smallest side should always be across from the smallest angle, biggest side should be across from the biggest angle. So if I look angle-wise, A is the smallest and was 42.9 the smallest side we had. Yeah. Angle-wise, B is the largest, so side B, 80.1, should be my biggest side. So that's a quick little thing you can do, just to kind of make sure that your answers seem reasonable. Alright, any questions on that one? Let's try another. So I again went to solve this triangle. Angle A is 28.8 degrees. Angle C, 102.6 degrees. And side C is 25.3 inches. So we can easily find the third angle. It's probably the best starting point. To find angle B, you'll just have to do 180 minus each of the other angles. So I get my angle B to be 48.6 degrees. then finding everything else, we have to use, in the law of sines, you have 3 formulas, or 3 little ratios. You use 2 at a time. Since I'm given side C, I'm definitely going to use C over sine of C. And we will first, let's find A. So that would equal A over sine of A. So side C is 25.3 over the sine of 102.6 degrees equals A, which we do not know, divided by the sine of A, which is the sine of 28.8 degrees. And then we can just use our calculator. We have to multiply over our sine. And we get that A equals 12 points, let's see, we had 3 significant digits for those, so we'll go 12.5 inches. And we find B the same way. Again, I prefer to use the numbers given in the problem whenever possible, so I'll do C over sine C equals B over sine of B. So that would be 25.3 over the sine of 102.6 equals B over the sine of 48.6. And we get B to be 19.4 inches.
So when you type in a calculator, do you do like parentheses 25 point or 25.3 over and then parentheses sine?
You can, or I've just been typing in like 25.3 divided by sine. It opens one, so you have to close it.
Okay.
And then I do the times. Like that. Any other questions? Okay. I'd like to do maybe 2 more examples. I want to do a couple word problems to make sure we can handle those. And then we are done for today. So, Kurt Daniels wishes to measure the distance across the river. He determines that angle C, so I even gave you a picture, angle C is 112.9 degrees. Also gave you angle A and side B. Find the distance across the river. So I was nice, I gave you a word problem, but I also gave you the picture. We are looking for distance across the river, so all I have to find here is A. So how many times will I have to do the law of sines? Just once. We need A, so we'll have to do A over sine of A equals, the only distance I have is B, so we'll have to do B over sine of B. I don't know A. Angle A is 31.10 degrees. I know my side B. Do I know angle B? No. So we've got to figure that out first, but that's not too difficult. We just subtract from 180. So 180 minus the other 2 angles.
36 degrees. So to get A by itself, we just have to multiply over the sine of 31.1. And I get the distance across the river to be 305.5.
You did 180
Minus the other two angles, the 31.1 and the 112.9. Other questions? Last one then. Why don't you guys read this for a second. See if you can figure out the information in the triangle before we do it together. I gave you this picture. We know the distance from A to B. So I gave you that one. I'm just going to kind of draw this down here. This is 110. We know the bearing. Now keep in mind this is the north-south line. When we measure bearing, it always was from a north-south. Remember doing that a long time ago? And I'm talking about these are on an east-west line. What kind of angle is formed when a north-south and an east-west form or meet? Yeah. So to find this angle in the triangle, you just have to do 90 minus 42. Okay. Then over here, this portion is a right angle because it's north, south, and east, west. So if you add your 15, 90 plus 15, we get 105. Then we could find our third angle, 180 minus 105 minus 48. And what do we get? 27. Okay. We want to know how far it is from the fire, which is at C, to the western station, which is here. So we are looking for this, which is side B. We have side C, so I'm going to do C over sine of C equals B over sine of B. So 110 over the sine of 27 degrees equals B over the sine of 105. Multiply that over. We get 234.0 or 234 miles. Because oh wait, I said nearest 10 miles. So what would I round that to? Nearest 10 miles, 234 would just round to 230. Any questions there? We have about 20 minutes left, and this is all I have for you today. So your homework, I did give you odds so you can check, make sure you're getting them right, but please have work to support your answer. So 3, 5 through 17, every other odd. And 25. So it's only 6 problems. And you have the rest of the hour to work.